Alright guys, welcome to this video. Today we're going to be talking about similar figures and triangles. And your learning goal for this one is that you'll be able to explain the similarity of triangles, and that students can recognize the connections between similarity and trigonometric ratios, which is something you may have already done. Okay, so at the end of this, you'll want to be able to describe similarity and scale factors, calculate unknown measures in similar figures, and prove the similarity of figures. Alright, so linear transformations. So there's something that you've seen before. So you might have seen rotation, where we get some figure and it gets rotated by a certain amount. Okay, we've seen reflection, where you get a figure and you reflect it across a line like this. We've seen translation, where you get some figure and you translate it by a certain amount. Now all these ones here, these are called isometries. Okay, so nothing changes about the general shape or the measurements of them. Okay, now this one here is a linear transformation, so it's, you don't retain the original measurement between points. Okay, so with a when we are talking about similar figures, we're talking about something that was once sort of this size, and now you're sort of expanding it out to make it now a much larger shape. Okay, and these sort of things become very important in an area of mathematics called linear algebra, and it's one of the transformations that you look at. So enlargement or reduction, and you end up creating a similar figure, which is something we're about to learn about just now. So figures are similar if one can be enlarged to be congruent to the other. Okay, so if we have these two figures here, we could say, well, you could make this one here a little bit larger, and then it would be then congruent to this other triangle here. Okay, now our corresponding angles are equivalent in similar figures, and the pairs of corresponding sides are in the same proportion. Okay, so we'll see what that sort of looks like in a moment. Now enlargement uses a scale factor and a center of enlargement. Now this scale factor is equal to the image length over the original. Okay, so if we've got this scale factor and a center of enlargement, so let's make this here the origin. That's our scale factor, that's our center of enlargement. And what we do is that a line gets drawn from there to through each point or vertex of our original figure. Probably going to go off the page. We'll see how we go. And then whatever the scale factor is, let's say we're going to make it equal to 2 for this one here. Okay, and then we're going to go. So this length here, we double it. Okay, so there's our new point here. Okay, so that length gets doubled to here. This length here gets doubled out to there. A little bit further, actually. This length here gets doubled all the way down to here, and our new triangle is instead this. Okay, so it's sort of like a doubled version of it. Okay, and the way we write it, if we had this being triangle A, B, C, and this one here, D, E, F, we write them by saying that triangle A, B, C is similar to triangle D, D, E, F. Okay, and that's they're written in a way so that, see how AB was the same as length DE. Okay, so we sort of try and write it like that. Those corresponding sides are in the order as you go through. Okay, and we also have that similar triangles test. So these are similar to your congruency tests, okay? So corresponding angles are equivalent for these ones and corresponding sides are in proportion by that scale factor, all right? Now, first one, angle, angle, angle. Now, please don't get confused with the congruency tests, okay? Because remember, angle, angle, angle wasn't one of the congruency tests, okay? But for this one, 34 is the same as 34, 83 is the same as 83, 63 is the same as 63 over here. They're all equivalent. These two triangles are congruent. So if we had, so we'd say sort of, you know, a normal congruent triangle ABC is similar to triangle DEF, if that was their names, okay? All right, now I'm just going to quickly make a little change here. Right, this makes a lot more sense now. So we've got two right angle triangles here. So right angle, hypotenuse, and a side is also one of the similar triangles tests. Okay, the way this kind of works out is we can remember our scale factor. Okay, so it's equal to the length on the image of 6 over the original of 4 of that corresponding side. And so that will be the same as the corresponding length of 12 on the image, and then 8 over here. Okay, so you can see that divide both these ones by 2, and you get the scale factor of being equal to 6 over 4 reduces to 3 over 2. Okay, so 3 over 2 is our scale factor, and so you can see that these are all sort of match up by that same proportion. All right, next one, side, side, side. Going to turn these into isosceles triangles. Okay, so side, side, side works for these as well. And so as you can see on our corresponding sides, 2 and 4 match up, 3.5 and 7 match up. Okay, so our scale factor for this one is equal to, so 7 over 3.5, which is the same as 4 over 2, and so our scale factor for this one is 2. Okay, so you can sort of see how that works. So side, side, side works, and side angle side is our other one. So 5 to 10, some angle, x, x. Okay, so remember, it's only the sides we're worrying about actually changing their measurements, whereas the angles stay the same. Okay, and 3 matches up with 6 over here, and so I'm sure you'll be able to see is that our scale for this one is also equal to 10 over 5, which is 6 over 3, which is the same as 2. Okay, so that's sort of how our similar triangle stuff is going to work. All right, so same kind of thing. Find those tests. Which one's going to work? Use that one. Okay, let's have a look at a couple of examples. Now, this one here, given that these triangles are similar, so we already know, state the scale factor and evaluate the unknown measurement. Okay, so let's have a look at this drawing here. Now, remember, if they're similar, the angles are going to be the same. So we already know this by looking at it, that this is 123 and this is 32, okay? Because we're not given these two, we're given them in this one. We're given this one here, but we're not given anything here. So this is our 25, okay? So when you're doing these kinds of problems, it's probably not a bad idea to sort of match those ones up, okay? So you probably want to say something like angle W is equal to 180 minus 123 minus 32, because of our 180 degrees in a triangle rule, which is 25 degrees. Okay, so that's just sort of setting that up. Now you know that this 1 kilometer is equal to this 0.8 kilometers. Okay, so let's find our scale. Okay, so therefore our scale factor is equal to gonna go with, oh, let's give this one a name, IJWX. Okay, so the scale factor, so we've got side UX is going to be over HI. Okay, so this one through this one. Okay, so that is 1 over 0.8. Okay, and that's going to be equal to 1.25. Okay, then therefore GI is equal to 1.25 times 1, which is 1.25 kilometers. And so there's our, well, we'll probably state it as x, therefore x is equal to 1.25 kilometers. Okay, so that's how we go about that. Find some of our missing things, figure out which side which, and then find the scale factor, then find your unknown lengths. Okay. Okay, so now this one, and prove that two triangles are similar. Now when you look at it already, you can probably see that you've got some sort of common multiples here. So 5 times 2 is 10, 6 times 2 is 12, but SS isn't enough to go on to build our case for proving that these two triangles are similar. So what we're going to do is let's look at these angles. Okay, let's call this one alpha, let's call this one beta. Okay, and we can say that alpha is equal to beta because of our vertical opposite angles rule. Now it doesn't matter what it is, we just know that they are equal to each other. Okay, so let's have a look at our other lengths then. Okay, so we can say MN over NP, okay, which is this over this, okay, is equal to 6 over 12, which is 1 over 2, okay. Then let's have a look at our other sides that we know, 5 and 10. Okay, so we go NQ over NO is equal to 5 over 10, which is equal to 1 over 2. Therefore, we can state now that we know that these are, so this is sort of saying that they have the same ratio between these. Okay, so therefore triangle MNQ is similar to triangle PNO. Okay, so see I tried to make MN, PNO, MNQ. Yep, so tried to make them in that order of the letters and the corresponding sides and that kind of thing. Alright, so there's plenty of examples there for you to have a go at. It's the best thing with this stuff is stretch your mind with this proof stuff, trying to demonstrate that different triangles are similar. And please come and see me if you have any questions. I'll see you at school.